Hi everyone, welcome to this video on the third lesson I'll be talking about in our Year 7 chemistry scheme. In this one I really want to introduce the idea of molecules and use that as a way of getting students to think about chemical formulae in terms of pictures of atoms joined together. So let's get into some examples and hopefully it'll become clear what I mean. So I like to start by building on what the students already know and kind of what we're doing here is refining their picture of matter. So I'm going to start by drawing a balloon. So this is something that we drew at least once, maybe a couple of times, I can't remember, in the particles and energy unit when they were looking at pressure and things like that. And what I might do is say, well, imagine this balloon is filled with helium. And they'll be familiar with helium balloons. They're the ones that float off up into the sky. Helium, it's this gas that makes your voice go squeaky and so on. And I might say, well, okay, if we were to look inside this helium balloon, what we would see is something like this. Look down at particle level and imagine what's going on. Well, we would see our usual picture of a gas. Something like this. I'm going to draw my arrows like this and so on. The reason I'm doing this is because I'm going to refine their picture, but I want to start with something that they're familiar with. And then, once I've reminded them of that, then I can make it a bit more accurate, let's say. Now, in helium, the reason I've chosen this is because in helium, actually it really does look like this. Now you guys will know this is because helium's a noble gas, but they don't need to know that for now. But what I'm going to do is say, well, actually, all we need to do in here to show how chemists think about helium as opposed to physicists is say, well, helium just looks a bit like this. Each of these atoms is a helium atom. In hindsight, I should have made my atoms a bit bigger, shouldn't I? But hopefully you get the idea. And what I want to emphasize here is that these single particles that are zipping around all over the place, bumping into one another, these are called helium atoms, and I might put He atoms, or maybe helium atoms, yeah, something like that. But what I'm emphasizing is that single particles are atoms. So then I might do another sketch. Now I don't always draw out the stick person, but I'm gonna have a go for you guys so you can see some live artwork. Let's see how this goes. My artwork is not the best. I'm going to draw a stick scuba diver. So let's draw someone like this. I'm going to draw this kind of oxygen tank on the back, like that. Maybe I'll do some goggles. Tube going down to it. Something like this. Now you might not want to draw this in class. You can think of your own examples, that's fine. But I'm going to show this as an oxygen tank. And that's something, again, from movies and things like that, they should be, hopefully, fairly familiar with. But I'm going to label it because my artwork is not the clearest. I've got an oxygen tank. Now, it's not about drawing a pretty picture here. It's trying to change the way they think about the world. So what I'm going to do is I'm going to zoom in on my oxygen tank and I'm going to show them what it looks like in here. But again, I'm going to start with the picture that they already know. So I'm just going to say, well, look, from a physics point of view, we can think about what's going on in this oxygen tank. Oxygen is a gas. You breathe it in. You sound a bit like Darth Vader, whatever. So I'm going to just draw the same picture as before. This is something that they will be familiar with. So for some purposes, this picture of what it looks like inside an oxygen tank is absolutely fine. But what I then want to say is, actually, and we could go into the history of this. I mean, at some point, I think it would be useful to talk about Avogadro and all these people who built on Dalton's idea that matter is made of these atoms, and they realized that actually, to make the numbers work, you must have diatomic molecules. I'm not going to go into all of that with Year 7. I'm just going to say, actually, what chemists found out is that the picture is more complicated than this. And I'm deliberately not going to put O's in here because I don't want to build that misconception. Actually, what this looks like is something like this. Each of these, what we were calling in the previous unit oxygen particles, is actually made up of two oxygen atoms bonded together. So I'm going to show it like this. And what I want them to see is that really it's the same picture It's just that in this case, each what we call the particle before, and I'm going to try and draw them in roughly the same places, each particle is really made up of two atoms chemically bonded together. And I mean, if you wanted, you could show those zipping about and stuff like this, like we did in the previous unit. But for now, I'm just going to draw them like this. But maybe it would be helpful just so they can see. What you want them to see in this lesson is that the two pictures are really just the same. This is just even more zoomed in on this one. So I then might show these moving around in roughly the same directions, like this. So where are they going? Like that, like that, like that, that. So they can see that these two pictures are talking about the same thing, and that's the really, really important point. Now, I then want to emphasize that these are not atoms. They are multiple atoms chemically bonded together. These are what are called molecules. And I want to show this link between the picture here, which is two O's joined together, and the notation O2, and we'll see lots and lots of examples of these. So I want them to make a link between that notation and this picture, and then I'm going to make sure that they know that these are called molecules because molecules contain these atoms chemically bonded together, and I'm going to keep repeating that throughout the lesson. So then we can look at some more examples. I think one that I've got, one that I think is quite useful that comes up in the slides is just burning stuff. So I just give a really simple example of burning a match like this. Hopefully none of them are operating on the Aristotelian picture of fire being an element by this point, but it's a good opportunity to unpick that misconception again. And what I would say is that when a match burns or whatever, in very, very simple terms, you can say, well, actually, there's two main gases that are formed. And again, if you want, you can do this. You can do this picture and do the gases. I'm just going to go straight to the punchline here. I'm just going to say that there's two gases formed. One of them looks like this. With three molecules. And you guys will already know, I'm sure, that one of these is a C and two of them are O's. So this would be C, O, O, oops, O, O. And then I'm going to label this and say, well, is it an atom or a molecule? It's a molecule because there's more than one atom chemically bonded together. And actually, these are CO2 molecules. And I want to really go through explicitly, these are called CO2 because in each molecule, each unit of atoms chemically bonded together, I've got one C and I've got two O's. That's why this is called a CO2 molecule. And this is what you get when you burn stuff. Generally, certainly things with carbon in, you get CO2 formed. And then I might tell them this other little story, which actually, if you don't get this complete combustion, they don't need to know why that is. But another gas that might be formed is this. I'm not too bothered about their knowledge of combustion here. I just want them to see lots and lots of these little pictures and relate them to the notation. You might get this other gas formed where you've just got one C and one O, like this. And actually, we saw this in the last lesson. I'm not sure whether they'll remember it, but you may wish to refer back to it. And what I want to do is emphasize that this would be different because this is just one C and one O. This would be a CO molecule. This. Now, in this lesson, really the main purpose of doing the teaching, I'm just going to label that as well, like this. The main purpose of this is, as I say, to link this notation to these pictures, and all of the examples that you'll see are doing that. One other thing that you might wish to talk about, though, is the fact that, well, let's look at these molecules. Let's compare now our O2 molecules to our CO and CO2 molecules. What do you notice about all of the atoms within an O2 molecule? Oh, they're both the same. So this must be an element. And we can come back to this picture. Now again, what I've seen usually, and how I've often done this in the past and not been very successful, is that I chuck all of this stuff into the same lesson. Actually, we didn't really worry too much about that when we covered this a couple of lessons ago, but now we can come back to this idea and say this is an element. But what about these two? These must both be compounds because they've got different atoms which are chemically bonded together into molecules. So these are compounds, like this. So it might be worth just reinforcing that idea, just so students are really, really clear. Now there's more examples that you can see. The last one that I might talk about here, I might come back to my diagram that I did earlier, which was on this reaction between hydrogen and oxygen to form water. And I could just then go through here and rewrite this. I might do this in pencil, but I might put something like, okay, each of these would be a H2 molecule. Again, I'm really just trying to reinforce the language. This would be an O2 molecule. And these would be H2O molecules. And again, you can then reinforce that idea of the difference between elements and compounds by comparing the composition of those molecules. This lesson really is all about practice. So there's loads and loads of examples. There's water, there's ammonia, there's others, I think methane as well. Get students doing them on whiteboards, get as much feedback as you can, and then just get them practicing loads and loads and loads so they can link this picture, this kind of picture with particles, to this kind of notation. In the next lesson, we'll build on this again and we'll start to look at chemical reactions. Thank you.